occasional series in YouTube tutorials. Today we're looking at fractal analysis of textures, and just to say this is not my work. The conference paper was written by Mr. Costa, Miss Triana, and Mr. Mamani. Apologies now if I got that right. So that's the paper is available there on researchgate.net, and Mr. Costa, if I just unzoom a bit, goes through the fractal analysis and why it's used, etc. And if you want to do that, you can read that to your heart's content. So I can shut that down. Next thing, the code is there on the MATLAB Central File Exchange. Okay, just to say, there we go. I'm Mr. Costa. So the code is there. You can download it there. I can shut that down. There's a bit of a tutorial there about how it works, but I've done this, so hopefully that will help as well. So the important thing here is to get this directory structure right. So we can shut that down. The next thing we want to say is the texture database that he tested it on is from Schmidt and Ponce, and you can get that there. So you have to download that yourself. Ponce's paper is given, just go up there. Now that's Ponce's paper where he did the different texture samples, so you can read that there, and that's hopefully you can just read it up there. Okay, and we saw that already. We can download that. Okay, we'll explain what that's doing there in a second. We'll just maximize that. So I've done nothing now, just to say the work is all Mr. Costa's. I've downloaded it. There's the MATLAB Central File Exchange. There's 25 texture classes. There's 40 samples each. We'll have a little look at that in a second. The code is there. And I just put in a section break, so you're just trying to build up the predictors there. And then we're just going to run this section here in a second just to see what goes on. So if we look at the documents, just go up there a sec. So there's all the Ponce's. There's 40 different, or there's 25 classes by 40. I downloaded them separately, but the important thing is you put all of them into one directory called images, and then there's another file to download, which is a text file, and that says T11, 38 is floor 2, T02 is bark 2, T13, 20 is a wall, and just go up there a second. I know I started having doubly. T01 is bark, T02 is bark, bark 3, wood 1. If we just click one at random, there's all the walls. So there's all the subfolders, but the thing is you have to put them all into one big folder, and then you also need that text file describing what each image is. So I've run the code. It takes a while. It can take 10 minutes, 15 minutes, 20 minutes to get to there. Excuse me a second. Just from start there. So you're building up F and L to there. So there's your 1000 by 21. So there's 1000 images, and there's 21 features. And Mr. Costa removed 3 of them to make it slightly more efficient. Then we're going to do a naive Bayes fit. So we're going to get that MB there. So that's going to be our predictor. We're going to read in a test image. and then we're going to run the Fractal here, the Fractal script on iTest, and then we're going to use the naive Bayes to predict whether it's, you know, granite, brick, marble, whatever. So I'm not going to run the bit of code up there because it takes so long. I'm just going to run this bit here. Just go to my editor, run section. Let that run a second. Sorry about that. And there's the answer that it's brick of type 2. And I have it twice there by accident, so there's the brick. And just to get the accreditations right, I took that brick from Wikipedia. So just to get that out of the way, that image is not mine. But I checked the copyright and it was okay to use that. That helps a little, and thanks very much for listening. Bye.